Properties of exponents and scientific notation. There are three things we're going to discuss in this lesson. First, we're going to review exponents, and then the rules of exponents, and then lastly, scientific notation. I'm going to list the vocabulary words. Please pause the video after I have all 5 vocabulary words on the screen. Write them down, and then I'll take a moment to go over them. Please pause the video. Right, first, a power. A power contains two parts of a number, a base and an exponent. So if you notice, the power here has two parts of a number, a base, that big bottom number, and an exponent, that small upper number. Those two numbers come together to form the power. The base is the big number. That tells you the number that is being multiplied over and over again. The exponent is the small number raised to the right, and that tells you how many times that base is being multiplied. And when those two numbers come together, it's called the power. Now, a power can be written in expanded form or exponential form. Expanded form is the 4 times 4 times 4. However, exponential form is just 4 to the third power. Simplify these expressions. 5 to the third power. Well, that's the same as just 5 times 5 times 5. Negative 5 to the second power. That's the same as negative 5 times negative 5. And then this says the negative of 5 to the second power, which is slightly different than what we had here in B. The parentheses make a difference in these two expressions. That's saying the negative of 5 times 5. In this case, the answer is negative 25. And then for D, variables work just like numbers. So negative g to the second power, negative g times negative g. A negative times a negative is a positive. So just g to the second power. Now the product rule of exponents. So 2 to the second power is 2 times 2. 2 to the third power is 2 times 2 times 2. So I have 2 2's multiplied together for 2 to the second power. 3 2's multiplied together for 2 to the third power gives me 2 to the fifth. 4 to the third power times 4 to the fifth power. I have 3 4's because 4 to the third, 5 4's because I have 4 to the fifth. That gives me 4 to the eighth power. B to the second power. Remember, variables work just like our numbers. B to the second power times B to the fourth power. There's B to the second. There's B to the fourth. B to the sixth. So let's look at our 2 and 3, we got 5. Look at our 3 and 5, we got 8. Look at our 2 and 4, we got 6. You can probably figure the rule to be. So the product rule of exponents says, when you multiply powers with the same base, you actually add the exponents. So the quotient rule for exponents. I have 2 to the fifth power, and I'm going to write that like 2 times 2 times 2 times 2 times 2. And 2 to the third power, 2 times 2 times 2 times 2, which gives me this. And then I'm going to simplify some of these 2's. And I'm left with 2 times 2 over 1, or 2 to the second power. Variables work the same way. X to the sixth power over x to the fifth power, simplifying my variables. When I have multiplication and I have multiplication in the numerator, multiplication in the denominator, I can then simplify x over x to 1, that to 1, that to 1, that to 1. I'm just left with x over 1 or just x to the first. So let's look at 5, 3. I got 2. 6, 5. I got 1. What do I do when I am when I'm dividing powers with the same base? You subtract your exponents. The power rule of exponents. So in this case, I'm taking a power to the third power and raising this power to a power. So I'm going to take, in this case, 2 to the third is actually the base of this exponent 4. So I'm going to treat it as a base and write it as 2 to the third times 2 to the third times 2 to the third times 2 to the third. Well, I can now use the product rule for exponents in this case because I have the same base and I am multiplying powers with the same base. So 3 plus 3 plus 3 plus 3 gives me 12. So look at what happens with the 3 and the 4 to the 12. Let's try another one with a variable. Y to the fourth to the second power. That's y to the fourth times y to the fourth. Or y to the 4 plus 4. Or y to the 8. 4, 2, 8. You can probably see what happens when you multiply or when you raise a power to a power. You then multiply these exponents. So please take the time right now to pause the video and try to work on some of these problems yourself. Please notice in some of these, for example, in D and E, you're only going to put together powers with the same base. So you will put down, since the 4 and the 3, that's just 12. Then you'd put the a to the third times a to the seventh, get that a to an exponent, and then b to the fifth times b to the 12th, and that b, until you'll have one expression when you finish. Please pause the video while you work on these and fill out the instructional notes. Okay. Again, we have a few more problems that we can work on. Simplifying each expression using the quotient rule for exponents, and we'll use the quotient rule for exponents and also sometimes the product rule and the power rule of exponents. So please pause the video and try to work on some of these as well. Don't let the fact that in some of these you have multiple expressions to actually simplify. Just take them one at a time. Look at the A's, the B's, the A's, the B's, but do not stop until you end up with just one base for an A, in this case for F, and one base of a B in this case. So you can keep on combining them until you put all your like bases together. Please pause the video. And now these three are a little bit more complicated. It involves all three of the laws of power we discussed. So please use your guided notes to try to solve these as well. Zero exponents. 2 to the 0 power is 1. 34 to the 0 power is 1. W to the 0 power is 1. If the exponent is 0, you can probably see and notice the pattern that the answer will always be 1. So the rule for a 0 exponent, any power raised to the 0 will always equal 1. Negative exponents. 2 to the negative 3. So what happens with negative exponents is you can never leave your answer with a negative exponent. So you have to eliminate the negative exponent. And the way we do that is this power always moves into the opposite position in order to remove the negative exponent. So for example, right now, since it's not a fraction, this 2 to the negative third is in the numerator. So I move 2 to the third in the denominator, and I can eliminate my negative exponent. And I have this place filler of a 1 here. So x to the negative second power will be 1 over x to the second. In this case, 3 times d to the negative sixth power. D to the negative sixth power, this is the power. So the 3 is not a part of the power, so it does not move into the opposite position. The 3 stays in the numerator, and then d to the sixth will go in my denominator. And then also, if I have 1 over c to the negative second power, remember, the negative exponent, the power that has a negative exponent, moves into the opposite position. So in this case, the c to the negative 2 will go into the numerator, and it becomes c to the positive 2. So the rule. So when you have a negative exponent, put the power in the opposite position, and the exponent changes its sign. So please pause the video. Your goal here is to simplify and make sure that all the exponents are positive exponents. Please note that on some of the instructional notes, some of these negatives did not come through when I saved them to the PDF file. Please make sure that the negatives on the exponents are there before you work the problem, because that will give you a different answer. I know in B, I don't think the negative 5 came through, or the negative in this 5 came through. I don't think the negative in some of these others came through as well. So just make sure the negatives are there before you work the problems. Please pause the video while you simplify these expressions. Next, scientific notation. When you have very, very large or very, very small numbers, we use scientific notation to write these numbers. And there are 3 rules or 3 steps we use in order to convert numbers into scientific notation. Those 3 steps are: step 1, first make sure you move the decimal point so that there is only one non-zero digit in front of the decimal point. 2, make sure you actually place times 10. And third, place an exponent on the base of 10. So let's try to find the answer in scientific notation from these decimals. In this very big number, in A, first move the decimal point between the 1 and the 3. Next, you must have times 10. And lastly, how many spaces did you move the decimal point from where it was to where it is? 13. In B, 6, you must have times 10. I did not move the decimal point at all. 0. In C, I move the decimal point between the 1 and the 3. I must have times 10. And then in this case, I move the decimal point in the opposite direction. So instead of it being 13, it would be an exponent of negative 13. And then lastly, the decimal point moves between the 3 and the 4. I must have times 10. And since I moved the decimal point to the right, meaning I started with a small number, I have a negative exponent, and I moved it 1 space, so negative 1. Please make sure you do the My Math Lab out of 5.1 and 5.2. Thank you.